In this video, I'm going to talk a little bit about vertical alignment. And the interesting thing in this particular case, and I've actually have a video of driving this road that I'll show at the end of my discussion, but this is US 64. It's between Morganton and Rutherfordton in the state of North Carolina, US 64 again. What's interesting here is that we have, from a horizontal alignment perspective, that's what we're looking at right now. We're looking at the plan view. There's no horizontal curvature, so it's perfectly straight in the horizontal direction, but we have a sag vertical curve that we're going to take a closer look at in Google Earth with the Google Earth profile view, looking at elevation data. I'll talk a little bit about kind of validating field data and more just how we can use that to start to identify vertical alignment. Of course, for more precise design work, we'd want survey grade information and data, but this helps us give us some idea of the vertical curvature and vertical alignment. I think it's really helpful in vertical alignment to have kind of a planning level view of what a roadway looks like. Of course, there's much more detailed methods to understand the precise alignment of the road, but I'm going to talk about just Google Earth data, talk a little bit about data quality, validating that data. But what we're looking at is a section of US 64. This is between Morganton and Rutherfordton in North Carolina. From a plan view perspective, so looking at horizontal alignment, this is a perfectly straight road, no horizontal curvature left or right, but there is a sag vertical curve here, and we'll take a closer look at that. The idea that I'm going to talk about here is how just to identify those key parts of vertical alignment. Where do we leave the grade and then enter the parabolic curve? Again, data quality is going to be a component of this. I've got other videos explaining some of the processes I'm going to use in Google Earth here. So if you're curious about that, feel free to ask me that question. I can point you in the right direction to some of the videos explaining that in more detail. But I'm going to keep this a little bit higher level. I do have a video of driving this segment of roadway. So if you wait to the end of the video, you can see how that actually looks from a driver's perspective. We're looking at it from that engineering highway design perspective. Going to look at those specific components for vertical alignment. So what we're going to start with is looking at the elevation profile. This is a nice tool within Google Earth. And so I've picked this segment of the road. I have a start point and end point, basically drew a line between those two. And this is what we have. Of course, this is not perfect. This is not survey grade, but it gives us a sense or an idea of what's going on. And there are some nice features that we see to help us get started in Google Earth. So we're going to see where we are on the map, on the horizontal or the plan view perspective, as well as on the profile view. So it's nice. You can highlight sections there and see both of these areas. One of the things we know we're interested in vertical alignment is we need an entrance grade and an exit grade. So we can highlight this segment. It looks like the average grade, the average slope here is negative 4.3%. So that's really helpful for us. And then coming out of the curve, our exit grade or our G2 looks to have a similar slope. You can see those are somewhat equal, and this is a positive 4.3% going up. So this is a traditional sag curve. We got the negative 4.3, positive 4.3. So if we're thinking about our parabolic equation and how to solve and understand more details about this, this is really helpful for us. G1 of negative 4.3, G2 of 4.3. We can even use this to identify the low point of the curve. Now, one of the things we should see here is we've got this strong dip here. Now, we should all probably rationalize, and we'll see it in the video at the end, there's not some big dip at the end. What this is representing is actually there's a creek or a stream underneath the roadway, and Google Earth is trying to give us the elevation of the Earth's surface, not necessarily of some of the built environments. That's why this is looking at the elevation of that stream at the bottom, not the roadway. So we've got to be cognizant of that. It's actually the roadway itself is going to be continuous here. So the roadway is going to look more like this, not having a big dip that obviously would be very disruptive for vehicles if it was present there. So I'm going to zoom in to this point as well. We can take a little bit of a closer look. Again, this highlighting really is helpful in Google Earth. So if I zoom in, we're going to be able to actually see this water feature here. So we can see there is a stream here at this low point. Looks like it winds around and then under the roadway somewhere in here. So this is what we're actually seeing with that dip in the roadway. Of course, it doesn't actually exist on the road. That's tracing that surface of the earth, the elevation of the earth. So we've got to be mindful of that data quality and validate these types of things anytime we're working with elevation data or any type of data we may be inputting into a model. So again, this is that kind of larger curve. The curve itself, we can probably see that it only is in this smaller segment. So what I want to do is I want to zoom in a little bit closer. I have another route selected here that we can view the profile in. This is a little bit of a tighter view of just the curve itself. We already know that there's that 4.3 and negative 4.3% grade coming into the curve. And what some of the things we want to look for is where's the curve actually starts, where's the PVC, where's the PVT. So we have our tangent coming in to the curve. I'm going to try and draw this as straight of a line as I can. Maybe let me draw a shape here instead of a freehand line. So I'm roughly trying to follow the slope of the grade. That's that 4.3% that's going out. And then we have our 4.3% on the other side. And the PVC is going to be somewhere in this area. Over here, we have the PVT over on this side of the curve. And then the PVI is where these tangents come together. PVI is there. Now for the PVC, what we're going to try and look for is where our curve starts to depart from the curve itself. It's a little bit tricky to do this. We'd like to actually look at the data a little more closely and see where we're seeing that change in grade. The data here are a little bit messy, but it looks like somewhere in this area is where the curve itself, the roadway, leaves that grade and starts to transition in our parabolic curve. We do see this nice parabolic shape. We do see that curve follows that parabolic shape we would expect. And then the PVT is probably somewhere in this area. So again, a useful tool as we're starting to understand vertical alignment and what's going on there. We can also get an idea or get a sense of what the minimum elevation is. Here it looks like the curve kind of has a low point somewhere around 1,066, 1,067 feet. Of course, with this stream crossing, we can't tell precisely, but if we put in the values, we know one of the important things is the elevation of the PVC. So we can see here what Google Earth is telling us. The elevation of the PVC is 1,169 feet above sea level. We can also look for that distance between our PVC and PVT. That's going to tell us the length of the curve, and that's going to be an important value that we are going to incorporate, as well as that negative 4.3% and then the positive 4.3% leaving the curve, the G1 and the G2. So with just a little bit of data from Google Earth, we can solve a variety of problems using the information here, our parabolic equation, customizing it for this particular curve, and again, solving for a variety of things we may have here. Depending on what you're using it for, if you're actually designing a roadway, you're going to want higher quality survey data, but this may give us an initial look and some of that higher planning level data we need for this. Next, I'm going to show a short video clip of actually driving this segment so you can see that horizontal and vertical alignment. Again, from a horizontal perspective, this roadway segment here is perfectly straight, but from that vertical perspective, we're going to see that sag vertical curve.